I would ask you to please take your seats. We're going to get restarted. And we have an exciting presentation. And so please take your seats. We'll start in just a few seconds. So yes, great. I'm pleased to welcome our sponsor, Over-IT, who, in cooperation with our member, Netznetz Österreich, will discuss innovating field service for electricity DSOs, the EVN story, which EVN is the parent company of Netznetz Österreich, in partnership with Over-IT. So I'd like to call to the stage Paolo Bergamo, who is the CEO of Over-IT, Werner Hengst, who is the Managing Director of Netznetz Österreich and a member of our Board of Directors, and Johannes Liedler, Head of Digitalization and Project Lead for Netznetz Österreich, our member. So please, they're all here. I'll turn it over to you, Paolo. Thank you very much.
Sweet. I guess I'm going to stay here. So first of all, thank you, Charles, and thank you to all of you, really, for being here today. We're going to talk a little bit about the sponsor today. Here is the speech you see. It's Innovating Field Service for Electric DSOs. I am Paolo Bergamo. I'm the CEO of Over-IT. And if I can tell you a little bit, a minute of my story, I actually spent 20 years in California building enterprise apps for a large SaaS vendor, let's say. The last product I built was field service management. And naturally, I got in touch with electricity companies. And I quickly figured out that the approach of most SaaS solutions, most software companies, which is to build a general purpose field service management solution and then sell it to all industries, it works most of the times, but it really does not work for this industry, for the electricity in general, for the utility industries. And I'm going to tell you why this industry is different. You already know this, but think about what's happening, right? Think about what's happening in the world, climate change, let's say extreme conditions. Let me switch to this so I can see actually. So extreme weather conditions. Think about what's happening with the Wind storm in Ireland. I actually lived in Santa Monica in California for 20 years. The fires, the two fires, the Eaton fire and the Palisades fire got really close to my house. That's pretty shocking, right? And there's also something else happening, which is a high demand for electricity right now. On one side, we're churning a lot of the energy into electricity, right? On the other side, we want to save the world, and yet we are demanding more and more services that require energy and electricity, right? This is happening as well. Think about the smart cities right now. Many more things you can do in a city and they require more energy, right? So, and which also means that we need to do the most we can do with existing assets, and while we are building more and more assets, right? And the third part, which is really what we focus on, is technicians. The truth is that with the obsolete infrastructure, the knowledge of the obsolete infrastructure right now, it's in the brains and the minds of relatively few folks that are from an older generation. And that knowledge risks to completely go away. And what's happening in this case? Well, we need to figure out, number one, how to get their knowledge in, somehow we extract the knowledge from these people, but at the same time, we need to seduce the new generations to take this type of jobs. And the new generations love digital tools, and right now we're not providing digital tools to be sexy to these people. That's where we are. Now, when you think about all of this that's happening, and you think about using a general purpose solution for this type of complex use cases, it just doesn't work. All of this really screams for a new approach in terms of digital solutions. Okay. And this is really, the way I'm thinking about this is there's three different pillars you need to follow for this type of industries. Number one is focus. You really need to have, you cannot have a general purpose platform. You really need to focus on high-end complex use cases. You shouldn't think about scheduling the technician. You need to think about mutual aid, like it's happening right now with EVN and E.ON in Ireland. you need to think about vegetation management, you need to think about emergency response, right? But you also need to think about making it easy for the technicians on the field, because these people don't use a traditional mobile, they cannot use a traditional mobile application. They need to use an application that can be used with thick gloves, or maybe voice, because safety is really important in this space. So focus is the number one pillar. The second pillar is about business continuity. Well, it is important. You know, traditional SaaS vendors really push their upgrades at their own pace, but what happens if an upgrade on the system actually happens during a storm in Ireland and integrations break and technicians do not know where to go anymore? These are the things you should think about when you choose a software, software partner, I should say. At the same time, the technician needs to be empowered to fully work for even up to a week, because all the data they need is completely offline, right? So this is what we think about, and cybersecurity, of course, which is super important. And the third pillar is really how you develop the software, how the software vendor develops the product. And I'm really proud and happy and lucky to be working with utilities, because the utilities don't really compete with each other. They actually help each other. And what is a better way than actually get all the brains together to actually guide the product roadmap with them? This is really what's behind the idea of Over IT. Over IT is the trusted digital partner for mission-critical operations in linear asset industries. This is all we do. We don't do other things. We are solely purposed to empower technicians, the silent heroes that actually keep the infrastructure running. And from a product portfolio perspective, I'm not going to take too much time on this, but from a product portfolio perspective, we have 3 solutions today. The field service management, which is really about dispatching the technicians and getting them the mobile application that can run with even up to a week completely offline. And at the same time, we have the field collaboration piece. You are a technician in front of an asset, you may need help from headquarters, right? And that's the asymmetrical type of field collaboration platform we have built. And Geo, and you're going to appreciate this, GIS is super important in these industries. At the same time, it is important to aggregate the GIS information from multiple systems so that you can make better decisions, and that's one thing we do. And the other thing we do with the Geo product is really making sure you reconcile what you have in the GIS database with what's out there in real life, which is the classic dilemma of as designed versus as built. They never match, and you need a tool that help you reconcile that kind of data, okay? From a customer footprint, do know that in 25 years of history, we actually deployed 200 customers worldwide. That's pretty impressive. And even more impressive, we actually have 200 customers worldwide. They are still running all on our solution. We didn't have any single attrition in 25 years of history. It's a shocking stat, but I trust me, it's a real stat. And this is why in the last years, we've been skyrocketing in the analyst quadrants up to the top right corner, I should say. This is just an example. This is the IDC MarketScape for FSM for utilities, specifically for utilities, and we actually are the most to the right if you look at this. I think you're probably bored to hear me talk about the company, and the best way to really present the company and see what the company does is to actually ask one of our customer and partner, I should say, to tell the story and how Over IT helps their digital transformation. So I will ask Werner to actually introduce EVN, of course, and then the digital transformation we do with them.
Yeah, thank you very much. Yeah, only for a few information about Netz Niederösterreich. It's a part of EVN Group. EVN Group is a multi-utility company. It is working in around 19 countries. And we have not only electricity, we have also gas, we have telecommunication infrastructure, we have wastewater, we have fresh water and district heating grids. But the main topic is about the DSO topic, that in 3 countries we have bigger organizations. The one is in Bulgaria, it is in North Macedonia, and also in Austria. It means we are very strong connected also to Southeast Europe in this case. And this project, what we will show you, is also directly implemented in all 3 organizations in the same time. And what is also important for us is how much is the number of technicians from our employees. This is around 3,000 people. They are now implementing in the field to work with this new field service management. And step by step we are going forward, and the potential in the group is of course much higher. Yeah, why we need further development in our organization? The one thing is the increasing of the renewables. As example, today in the opening session it was mentioned 20–30% more increase of investments. In our case, it is 3 to 4 times higher investments in the last years as it was before 2020. And therefore, with the renewables, we have to increase the investments, and this shows us also increase of the costs of the net grid tariffs. And this is a huge pressure now also from the regulatory issue, because in the last year, our grid tariff increased around 30%, and this is a huge impact, of course, of the costs of the customers. And these investments also have an implementation about our employees, because we need more assets. More asset means in the future also more employees in our companies. And if you see this, when you have a new employees, the education is not the same as it was in the past. We have a churn rate what is much higher than in the past when you look backwards 20 years ago. And the same is also that we have a wave of retirement in front of us with this baby boomer issue. And this brings us to the topic, we need the last point, increasing of demand of digitalization. We need new technologies. And this is the case was also in the opening session was we need also more efficiency in our organization. And for this, Johannes Liedler will now bring you the details of our project together with OVIT. Thank you.
Yeah, thank you. What is the challenge that Werner just explained in 4 bullet points? It's about the challenge for us, digitalization of our asset maintenance. And we have 4 key figures that we are addressing at the moment. The first is, and I'm sure that many of you DSOs know about this, you have a very distributed source of asset information. And we are on a journey here from the left to the right, and we want to bring the asset information to a single point of truth where we know where our asset information is and that it is true where it is. And at the moment we also have limited asset information in the field, so we don't know much about the assets, we don't have sensors installed, but what we want to achieve, we want to implement more sensor data, more real-life data, and therefore make things like predictive maintenance possible. At the moment, and Werner talked about this, we are running the operations in 3 different countries. We have very different ways how we document all our work, and it is our aim to create digital workflows that are the same in all the countries and to get rid of these individual processes. And this also needs a change of the organization, not only about the way of the thinking of the employees, but also to build the organization around the new processes and make dispatching of workforce in an optimal, effective way possible. And this leads us to this transformation journey that we are describing here, starting what we call a target operating model, so changing the operation, the organization around our technicians, about our field technicians that enable introducing new ways of work. And asset performance management systems are crucial in this role to actually generate work orders for the technicians in the future and have a fully digitalized process end-to-end in the whole chain of operation. And the end, and which is actually in touch with the technicians, with our 3,000 technicians in the 3 countries, which are highlighted here in the background map of Europe, in Austria, Bulgaria, and Northern Macedonia, is the field service management. And we are partnering here with OVA-IT and started the journey in 2023 after tender procedure. And what we want to achieve are 5 main goals. The first goal is, with a digitalized way of working, we want to enhance the customer satisfaction so that the customer is treated as good as possible by our technicians. The second goal is to support our employees in the field in the best way possible with new information from past inspections, from past processes, live on the devices in the field. This also should improve efficiency, not only by having good information and the right tools in the field, but also in optimization of the planning of the tasks and their operational tasks and processes. Through digitalization, we can enhance then a high quality of data and enhance a high quality of processes, harmonize processes, as I said before, in not individualized processes like in the past. And this will lead finally to a transparent status of our tasks that we have to provide for our customers in all dimensions, for the customers, for the technicians, for the management, and for the stakeholders itself. And now some short words about the next steps in this transformation. Again, these 3 crucial initiatives, starting to reshape our organizational structure. It's the first arrow. In autumn 2025, we will change the way of working for our 1,000 technicians in Austria, step by step, not at the same time, because we're also implementing SAP HANA at the same time. So you know it's a great stress on the organization, and we want to adapt slowly for everybody so that it is achievable. Then, supporting this, we will, what we said before, the single point of truth, introduce systems that actually support these processes and the organization and give digital information and data to the field service management, which is the last and dark red stream that we will launch now in February, the next step of our implementation project. And therefore, again, coordinated and harmonized with the 2 other initiatives, we will by step introduce new processes and new digital ways of working to our technicians. I've talked a lot about the 3 countries and the processes, and I just want to highlight that we are running this project structure in a parallel way. We are introducing different processes at the same time in different countries. And I'm sure some of you are maybe also interested in this kind of approach, so feel free to approach to us in the coffee breaks, how we achieve this. Partnering with OVA-IT, they can make it possible to run multiple projects in different cultures, different languages, and different processes at the same time to rise the best way of synergy possible. And you see very multiple processes. It's not only maintenance, but this is our key focus, as we have already installed a lot of smart meters, so metering topics are not the first on our agenda, but maintenance and construction will be the processes that we want to digitalize to boost us into future. And I think we have found a great partner for innovating field service management for electric DSOs, and as Werner said, also for gas DSOs, as we are. Thank you, and Paolo.
Thank you, Johannes, and thank you, Werner. It's been truly a blessing to find you as a partner. Truly, we are co-developing and enhancing the product together. So thank you so much for the partnership. So here is a little bit. I'm going to wrap it up quickly. This is what I would like for you to remember out of this presentation. OVA-IT is the trusted digital partner for mission-critical operations in linear asset industries. We help our customers to run the vital systems. We do it with sustainability in mind, because at the end of the day, we are about efficiency for the technicians. But the last program I would like to tell you a little bit about is our focus on humanitarian aid. If you think about this, our platform is so mission critical for many mission critical infrastructures. It's even more mission critical when it is about humanitarian aid.
In today's world, humanitarian emergencies are escalating due to armed conflicts, natural disasters, and the devastating impacts of climate change. In these moments, humanitarian organizations are the beacons of hope, but igniting that hope is far from easy. Delivering aid in these environments is a race against numerous obstacles. Complex distribution networks, transportation hazards, damaged infrastructures, and emotional distress. Yet, there is a way to overcome these challenges. Field service management technology addresses the needs of humanitarian organizations as the driving force behind any collective change effort. Whether it be logistics, food delivery, wash, health, shelter, communications, or education, OVRT is the trusted digital partner for mission-critical operations, bringing field service management expertise and innovation to empower humanitarian organizations in managing priorities and ensuring help arrives where it is needed, when it is needed, building a fairer, more equitable, and sustainable world. Together.
Here is our philanthropic program. We call it Tech for Aid. It's got 3 simple pillars. We provide our solution to nonprofits that deal with humanitarian crisis. And I'm really pleased to tell you that today we are working with Red Cross and United Nations. We also put as service the expertise we have in-house on processes and, why not, implementation of the software to the same nonprofits. And the third pillar is we actually been hiring refugees, tech-skilled refugees from all around the world. And we're really proud of this. I hope you appreciate it. This is it. This is it. I hope we will like to work with each one of you. We have a booth right outside, and with this, I'm going to give it back to Charles and thank my guests from VVN.
Thank you so much. Thank you, OverIT, our sponsor today. And thank you, Paolo, Werner, and Johannes. Thank you so much. And with that, I will call another sponsor, Mark McGranhan from EPRI. And we're very thankful to EPRI for also being a sponsor today, the Electric Power Research Institute. And I'll let Mark call his panel.
All right. Why don't the panelists come on up here while we're doing this, and I'll say my 2 cents while we're doing that. We got 6 people on this panel. We're talking about resilience in this session. I'm very excited about that. I think it's one of the most critical ones out there that we have to deal with from an innovation point of view. There's so much opportunity for innovation and how we deal with resilience, but the critical thing is how important resilience is as we face climate change and as we try to electrify more and more of the energy system, and we'll hear about that with the panelists today. I want to thank Charles and Johan and the entire E.DSO team for including EPRI in this gathering today. It's very exciting. We're delighted to be part of it. Innovation is so critical overall in the energy transition. It's kind of the DNA of EPRI, so we're very excited to be talking about innovation and coordinating with E.DSO around the innovation needs as we go forward. Coming from Dublin, I'll just add my congratulations and thanks to the ESB and Northern Ireland Energy teams. You know, it's been 2 weeks now since we had Storm Éowyn in Ireland that knocked out more than 1/3 of all the customers on the island of Ireland. Amazing. On the total island is about 1 million customers that were out of service, and ESB's network was about 800,000, and Northern Ireland got their customers pretty much back in service early this week. And there's still customers on ESB systems that are out of service. So thanks to all of the E.DSO members from around Europe that sent crews to Ireland to help with the restoration, generators. I think it's very appropriate that we just heard from over IT and field service management systems, because as we talk about resilience and we need to do this kind of mutual support when we have major events like this that are much larger than can be handled with the workforce and the equipment that we have as a utility that's designed to be doing day-to-day reliability, getting support from other utilities is absolutely critical. We have a very structured system for that in the States. It's a little bit less structured here, but it is there. And when those crews come in, they need to be able to work with the systems that ESB has. So kind of having common approaches to the interfaces and the field service systems that are used to manage those crews is absolutely critical. So very timely. All right, we got a great range of perspectives, from policy to DSO perspectives to research, and each of our panelists, we'll give them a couple minutes to kind of give a perspective. We'll try to have time here for a few questions. I have a few, and we'll see if we can support a question or two from you guys as well. So we'll just go one at a time here. I'm going to start with Jan Duzic, who's the Deputy Director General of DG Climate. So he's going to start us off with a little bit of a policy perspective on the critical nature of climate change and where we're going with electrification and how resilience plays into that. Thanks, John.
Well, thank you very much, Mark, and good morning or almost good afternoon to everyone. Thank you for the invitation, and pleasure to make the connection between what we are working on in DG Climate of the European Commission and how this all connects to the provision of electricity and how we see the path together on the way forward. So the European Union is a leader in leading the global climate action. We will continue on that path. We have the climate neutrality objective of 2050. We have the legislation until 2030, which should reduce our emissions by 55%, and we are on a good track on delivery on this 2030 objective. Obviously, what the discussion is on now at the moment is how we can combine the decarbonization with the competitiveness in Europe, and this was well described already in the Mario Draghi's report in the autumn, and this is also well described in the competitiveness compass that the Commission has released last week, and this will feed into a list of concrete measures that will pave the way, starting with the Clean Industrial Deal, going into specific sectors, but in essence, going back to electrification. This is something which is at the center of our efforts, and we know that we have expensive energy in Europe at the moment, and we firmly believe that an essential solution for bringing down the energy prices is to provide clean electricity as quickly as possible and bringing down the cost and being able to get it to the customers in Europe through grids, through storage, etc. So we have a common task. We have a vision on climate. We will have specific roadmaps that will be developed over the coming weeks through the tools, through the action plans of the European Commission, and I think that we have the solutions that we can design together.
Great. We'll be looking forward to that. I'm going to move on to Louis Cunha as our next panelist. Louis, very familiar to everyone here at E.DSO. He's a Director of European Policies and Projects for E.REDIS, but also the chair of ETIP-SNET, and that's very important as ETIP-SNET kind of recommends strategy priorities for research initiatives in Europe. And so as we talk about innovation, that's absolutely critical. Let's include resilience in that set of strategies.
Okay, thank you, Mark. Good morning or good afternoon to everyone. So honestly, I don't really know what to say, but I'm trying to go in the direction that you mentioned on the innovation direction, trying to put a little bit ahead of EDIPSnet, not only being a DSO, but also as chairman of EDIPSnet. I was listening to the first panel, and I think that we should just make a disclaimer here, just about the DSO part. So basically, I think what DSOs do is prepare, operate, and react. And I think resilience is part of all these three vectors. Preparation, which is planning, operation with normal real-time connection and operation of the network, and the reaction, which goes directly to the storms and climate events that we are facing right now. Having said this, I would like also to go a little bit backwards. There was a question, a very nice question, after the first panel session, on why we are lagging behind when it comes to flexibility. And I think that we also need to think about, be very pragmatic, need to have at least 2 or 3 or 4 pillars that we bear in mind. The first one, without any priority at all, the first one will be the need for grid enhancing technologies, what we call smart grids. So I think this is a must. And the idea behind this is that we should exploit to the utmost extent the capabilities of the existing grid. I think we all know that, we want to do that, and it's out of discussion. The second point is that we need to incorporate flexibility. And having said this, I'm not putting a priority on this, but I'm saying at the same time that there is indeed an embedded priority. So if we have a smart grid, if before deciding on investments, we look at capacity of the consumer side and generation side to provide, and I'm saying this, grid-friend flexibility, and I will stress grid-friend flexibility, because it's driven by the interests of the system and not by the supplier or any other player interests, then probably we'll have capacity to reduce the need for the last pillar, which is the need to do investment in traditional hardware. But again, what regulators, it's my understanding, what regulators are doing out there is waiting to see what is coming with the first pillar, the second pillar, and then decide on the third one. And the thing is here is that they say that DSOs and TSOs want to reverse the order, to put first investment, then to look to the smart grids, and then to look to the flexibility. And I see, in my opinion, I think that we need to bring all together. I think it's every time that we need to do a single investment, we need to make the balance between these 3 value propositions. And that means that we should not delay the investments in the network. So just make this point to be very clear on this, because I think we always hear this discussion about flexibility, that we are stopping flexibility. I think it's not the case. I can even advise, it's not my role here today, but I can even advise you to look into our distribution network development plan in Portugal, where we do exactly this. We first test flexibility, we make sure that we have a smart grid, and then we go for the last stage, which is the final investment. Just also to share with you, when it comes to innovation, a couple of figures. These are my own figures, and please apologize if I'm doing it wrong. So I was just thinking a little bit about TSOs. I'm not a TSO, but I also like very much the TSOs, and we have a good cooperation with them. So if we look to the Picasso and these related market initiatives, I think they started in 2007. It took for the vast majority of the TSOs 5 years to implement these new market capabilities. But there are still some TSOs out there that are still struggling to implement this. And we have 43 TSOs around Europe. Now imagine what happens with the DSOs. I don't even know the figure, what is the real number of DSOs across Europe. I should know it, but I don't know it. But the fact is that when you look to the network codes, I think it was Santiago that mentioned network codes. The average time for a network code to go from the starting phase to the implementation phase should be something between 5 to 10 years. 5 to 10 years. And you need to think that before the network code, there is also the policy time. So it means that every new innovation that is going to impact the several DSOs across Europe will take us at least 10 years, and on average, I will say something between 12 and 15 years. Now let's compare it with the situation that we have now with AI. So we all know about these discussions last week, DeepSeek, OpenAI. Just to disclaim also, I've been using DeepSeek for the last 3 months, I would say. And what happens indeed is that this is our news just coming to a kind of manipulation of the use of these kind of tools. Because in reality, what we see after this news is that every time that I go now to DeepSeek, it's very, very difficult to use this kind of platform because it's always down. So you see that this is coming to geopolitics. The fact is that Europe, we stand alone in this process and we cannot do it. We have to accelerate the speed of innovation. This is critical. Now looking into Horizon Europe, Mark probably is not with us now, but Mark, I would like to say this also to Mark. If we look to the Horizon Europe or Horizon 2020 or even the Digital Europe program, and we take notice of the time that takes from each single innovation coming from this process to go to implementation, I think it's a mess. You see, when you compare the speed of innovation when it comes to AI with this one coming from this side of the Horizon funded projects, we see there is no way to compare it. So let's think a little bit deep about this and change a little bit our mindset. I think this is what we really need when it comes to resilience. We need to start having a collaboration mood and just make sure that we have good conversations with regulators, policymakers, be transparent on the process, be clear on what we have at hand, and also acknowledge that we are lagging behind. And that is, for me, probably the most important thing. Because every time that I try to address a new topic, the first thing that I acknowledge is that I know nothing about the topic. So when it comes to innovation, I think we are very innovative, but if you compare our sector with other sectors, we are still lagging behind. And if Europe wants to lead this change, I think we also need to acknowledge, first of all, this, and then to work together in order to achieve the so aimed resilience and capabilities.
Thank you. I think that aligns with some of the comments from Clara this morning as well about creating some metrics and incentives for innovation that we can track from a performance point of view as regulators work with the DSOs as well. We're going to move on to Garrett. You're next. Garrett Jan Schaefer and I were together on a panel in Belfast just last fall on the Global Innovation Summit, and we had a great discussion there around innovation. And Garrett's general manager of Energyville, which is a living laboratory for innovations in energy communities, and be interested to hear your perspective on how resilience plays in that living laboratory concept.
Yes, thank you so much also for inviting us and becoming a partner of this event as Energyville. I'm indeed the general manager, so I have to get information from all the strains of research on this issue. And let's just rephrase resilience as how do we keep the lights on? In normal circumstances and also in extreme circumstances. So we have to design for availability, but also for failure and to see what we can do then. But before I go into what is needed on the low voltage level, because I'm focusing on that today, I want to stress the urgency of this topic. Why is that? With all the models that we do for a decarbonized system, we see that we are going to electrify a lot. And with a lot, I mean a lot. Today, only about 20% of our energy demand is in the form of electricity. But if you are going to electrify transportation, if you're going to electrify heating and cooling, if you're going to electrify the industry, we go to maybe 60%. So we're going to reduce our energy, but we're going to increase enormously our electricity demand. So it's not a 40% increase by 2040. It will be 2 to 3 times more by 2050. So first of all, if you want to keep the lights on, we need to build. Build, baby, build. And indeed, then we get to all these issues that we discussed today. We need to build and also allow building, allow financing in more uncertainty of the future. But if we don't do it, we will certainly not get there. And there are already some countries, and I'm working in Belgium, I'm coming from another country, there are already some problems in grid congestion, and I think that's very important. We need to build a lot of new cables, of new transformers, of new feeders. Okay, first thing, to keep the lights on. Secondly, if you really want to use all these new resources and also to know how they react and how they can be leveraged at the low voltage level, we need to get to know the low voltage level. And in fact, most of the DSOs don't know it. They know it maybe for 85%, but not for the 95 to 100% you need to know it. That's what we call connectivity. That's of course the result of the fit and forget policy that we have done for a long time. Also till today, all the connections are not documented. Which line is connected to what point and which phase of those lines is connected to what house. It's not well documented. Of course, there are more and more tools, and there are some companies around here, and also there is also a tool developed by EnergyVille itself. It's called PIRI, to use AI to get to this first step. Because if you don't know how the grid is, you cannot make a model, and you need a model to be able to act. A model for the future, for different scenarios for your planning of building, but also the model for the next day or the next hour to see what's going to happen if you can do something. And for those models, you need to know the connectivity, and also you need to go deeper into the profiles that will exist in the coming years. So what is the profile of a household with or without an electric car, a PV installation, but maybe in the same feeder there's also a butcher or another kind of industry, and you know it at that level. And we are not there yet. We have to hurry up getting to that knowledge. And then if you have a model, of course, there are several things you can do. You can start using tariffs. There is, for instance, in Belgium, a capacity tariff. So there is already kind of signal that if in one area there is a lot of, let's say, cheap electricity, that people are curious and careful not to use too much, because then they will be charged more. So that's already something that's happening. Should it be maybe more dynamic? I guess so. And also we see already market-based trials like GoPax in the Netherlands. I think it's also good. And finally, and that's something that I've seen in the south of Australia, there's just the technical use of flexibility, meaning that if you know exactly that tomorrow between 2 and 3, for instance, there will be too much PV injected in the grid, you just tell them that at that moment you cannot inject more than 1.5 kilowatt per phase or something. And that's happening in South Australia now. They're using it, they're implementing it, and it's working well. And in that sense, that problem is more or less solved. So there are several levels, and I think there have been already some tryouts in the world. And I think it's time to use them and implement them and see if you can learn further. And of course, EnergyVille is always happy to assist that in the living laboratories, indeed. Thank you.
Great stuff, thanks. And that leads us very nicely to Anto, and Professor Antonello Monti is the director of the Energy Institute at RWTH Aachen, and leader in the area of modeling, as Garrett was talking about, and one of the leaders in the Twin EU project here in Europe. And be interested in your perspective, Anto, on kind of the innovation needs and the role of modeling and digitalization.
First of all, thank you, Mark, for inviting me here. It's a pleasure to be in this panel. First, let me say I'm here not only as RWTH, but I have to acknowledge also Fraunhofer, because I'm leading the Twin EU project as part of my work in the Fraunhofer FIT. And yeah, I see the activity in the Twin EU project as a key element in this discussion about resilience, because the digital twin can be a great element of support when it comes to resilience. But first of all, I would say we need to think about what we mean by digital twin in this respect. Digital twin is not only about modeling, part of which I love, of course, but it's an integration of at least 3 elements: the modeling, the data acquisition from the field or from other sources, and the post-processing of the information. Why? Because a digital twin makes sense if it's not just a picture that we did out of some preliminary data, but it's a living picture that changes with time. And that's one of the biggest challenges in terms of digital twin. I think we know how to build a model of a grid for many years, but what is hard is to have something that evolves with the reality. And that's where most of the challenges are. And when it comes to this point, critical is data acquisition. And when we talk about digital twin in the context of the grids we have today, this is a quite complex process because it's not just about data that grid operator can directly access through their own asset, but through the possibility of other source of data, which means interaction with other stakeholders in the system, starting first of all here from the DSO perspective, the TSOs, but also the interaction with other data sources. And that opens up the role of data space in making this possible, because we need to have a real situation of free flow of data. So unlocking the data is not that we don't have data, but we don't have the mechanism to easily share with proper rules and with data sovereignty the data in the way the digital twin can evolve. I think I recognize the European Commission is doing a great effort in supporting this process. We had a lot of innovation actions. Now we have in the Digital Europe the first implementation action with a project that Insieme that should start very soon. But this is a key element. We all need to work together. Building a common European energy data space is a key element. We see that in Twin EU, where we are using data space technology that we developed in the previous OneNet project. That's the best way to facilitate the availability of the data that makes the digital twin a living animal, because that's where the digital twin can make a difference. And specifically going to the use of the digital twin in relation to resilience, one of the aspects is, okay, when we have this living picture, we need to project the picture in the future to be ready. So it's awareness of what we are today and understanding where we could be later to anticipate issues. And that's not the normal forecasting when we talk about resilience, but it's something beyond, because the Ireland example is the perfect one. We are talking about low probability, high impact type of events. And that's not what normally forecasting does. But here we have new tools available, because that's where generative AI is good at, and that's where I think one of the good use cases we can look into to understand how Gen AI can change the way we run the power system. In that respect, I would like to mention, and having Luis here, I have to, within ETIPSNet, we are doing a great effort, and we are all invited to support and help on making a position paper on the application of generative AI for energy systems and electricity system in particular. The effort is led by Luis. We have a very ambitious agenda, but we had a very good, successful first stakeholder workshop last week where people have been engaged, incredible participation. But we all need to think about together because identifying those critical use cases, like, for example, how the forecasting of low probability, high impact could be done and should be performed by Gen AI is one, but how to do it without the technology, without the best practice, what are the policies that we need to suggest? These are key actions where we need contribution of everybody sitting here. And then project like TNEU can use those and integrate in a vision of a digital twin for Europe.
Thanks, that's great. And the webcast last week, workshop on that AI applications white paper was very good, and I encourage folks to go out and access that. The recording is available, and there'll be future webcasts on that as we finalize that document. So jump in and participate. It's probably the most important topic that we have going on now is how we can collaborate and take advantage of artificial intelligence for such a wide variety of applications, and resilience and all the aspects of it, from forecasting to infrastructure requirements to response, are appropriate. All right, we're going to go to Daniel next. Daniel Davi-Arderius is in charge of new network business opportunities at E.DSO. He's with Enel Grids, and interested in kind of from an innovation perspective, another DSO perspective in terms of what you're working on and from an innovation point of view around resilience.
Yes, thank you very much for inviting us to participate in this very interesting event and panel. Yes, I would try to develop, I think once we agree we need to improve resilience, we will have more frequent extreme weather conditions. I will go back to the question made this morning by Clara when she asked us if the current regulation designed 20 years ago is still valid. And I think that if we look at that regulation was designed 20 years ago, especially to improve cost efficiency for DSOs. There was very huge incentives to decrease our operating, our CapEx costs. But now we are learning that regulation was very efficient to decrease costs, but needs some adjustments to make our grid resilient. And I will put 2 examples on how I think this could be improved, the gap we see, and how this could be improved. If we need to fit a city with a substation, the most cost-efficient solution is building 5 overhead lines with the same track directly to the city. We are learning that when we have very extreme weather conditions, we may lose all the 5 lines. So the most resilient solution could be some of these lines should be underground lines, or we need 2 different tracks for the same lines. As another example, we are designing substations. We have N-1 at transformer level, but we are learning, we are experiencing in some cases that we lose the whole substation. We may have flooding, we may have very extreme weather conditions, so we need to start in some specific cases to assess N-1, for instance, at whole substation level and have additional redundant solutions. So the question is, how can we improve our frameworks to consider that? And in our group, in Enel Group, we share best practices, and I would explain briefly the Italian market we have for DSOs, where some grid investments are assessed based on KPIs. So some grid investments are assessed to evaluate how they contribute to the reliability on extreme weather conditions, how they improve the time recovery under some cases. So we think that this kind of incentive regulation would provide additional incentives to make a bidimensional regulation. So cost efficient, but also reliable solution. And a last point I want to just briefly develop, we are discussing a lot about flexibility. We all trust on flexibility. We need customers be active. But once we have the floor, when we engage people, I think we need to keep moving. And I think another point we need to start developing is this morning it was also mentioned, we are making a power system close dependent on external sectors that we are out of our control. I mean, flexibility means we have small units reacting on seconds, minutes, and hours. And what happens if communications fail, are not enough reliable? Communications that at the same time are depending on our power system. So I think we need to start thinking different. Regulation has been quite intersector. So we are quite used to rural energy sector on one side, communication sector on one side, and I think we need to start joining together very different sectors. Anyone knows all about everything. Each one knows about his world, and I think we need to start collaborating and exploring how we could identify gaps, improvements in order to avoid consequences which could affect resilience. Thank you.
Great, and I think the Italian performance incentive approach is a very good example for really the rest of the world to look at. There's already been some good outreach with Brazil regulators in terms of looking at that as best practices, and I think there's a lot to be learned there. We're going to finally get to Henrik Nystrom, Marketing Manager at Varberg Energy, and representative of the Project Copper, and I'm looking forward to hearing about kind of the local energy aspects and the role in resilience as well.
Thank you, Mark. Yeah, thank you for inviting me as well. So the Copper project is a part of the North Sea Interreg project, and we are a couple of people that is representing like 6 different cities and other companies as well. E.DSO is presented, And yeah, as you said, Mark, we are looking at the local energy action plans where the DSOs and the cities is collaborating close to make sure that the cities can develop and grow in its speed that it deserves. I know Fluvius is close collaborating with like City of Ghent and Antwerp when they are building or looking at all full electrical neighborhood, as well as yeah, looking at what happened with the mobilization and how can the DSO and the city collaborate to make sure that this electrification can be done. So that's more an operative way of resilience. Then we also have these cities looking at more of an adaptive way, like Varberg, where I live. I had the benefit to invite all the project participants to Varberg last year to show them the battery park that we have, and as well as the home batteries. We have created a platform called Netflix. It's not Netflix, it's something else, even though it's like streaming services. So Netflix is the platform where we connect a lot of flexible assets, like home batteries, EV chargers, grid batteries, windmills and stuff. So either if you are, even if you are a producer or a consumer, it's very important to adapt to the flexibility network. So we have about over 1,200 connected EV chargers and about 1,000 home batteries that we can control, and the customers. You heard? I heard. Santiago spoke before here in the panel before the coffee break. He said it's very complex with flexibility, and I agree. And it's very, very important to include or involve the customers in it because the customer is a very important part of the flexibility platform. So when we are doing the local energy action plans in the copper project, it's it has to be like 4 areas. You have to look at the production, you have to look at the energy consumption and the distribution and also the flexibility. So 4 parts. Everyone has to be there. You can't forget the flexibility part. Yeah, that's kind of what we do right now. And in Varberg, the flexibility grid is still growing. I think we have like 40 megawatt flexibility in our platform right now. And as a builder of new renewable energy production, like even if we are building windmills or solar parks or whatever, it's our responsibility to also add flexibility in it. So we say in Varberg that if we add 1 megawatt, for every megawatt renewable energy production we build, we also have to add 1 megawatt flexibility in it. So that's a standard for us. And also now in Sweden we have more and more electrical boats coming up, which I'm very glad of. Yeah, in Sweden we have just like 5 months the boat is in the water, the other months is on the land, and when it's in the water it's like 95% is just laying in the marina. So if we can connect the battery in the boat to the marina, we can use the battery more than just driving the boat. So yeah, so it's happening.
Super. We're going to come back to relationship between flexibility and resilience in a minute. And I'll also, if anyone has any burning questions, be thinking about them. We'll give you an opportunity to ask those in a couple of minutes. And just as a warning, we'll wrap up in our last 5 minutes with going across the board on your top priority for innovation in the resilience space. But first, let's to Jan and Louis, in terms of the impact of climate change and what we're doing from a European Commission point of view to provide say, better information about the impacts of climate change on the grid? What do we have available in terms of forecasting and information that we can take into account as a DSO? And then, Louis, how can we take that and use that in our planning framework for investments to think about how we might change our investment strategy to deal with climate change for resilience?
Well, resilience, as the title of this panel, it can be understood in many different ways, and obviously I understand your main preoccupation about the resilience of the grids. From our Klima perspective, resilience is more, well, it's related, but resilience to climate change that is happening. Obviously, the emissions that we are producing today will have an impact 20, 30 years down the road. So we are facing a climate change which will be not 1.5 degrees, but for Europe it's about double. So we are in the world where we will need to adapt to climate change, which is about 3 degrees centigrade if we manage to keep within what we have committed in the Paris Agreement. So quite significant changes with extreme events, etc. We are embarking now, or we have embarked last year on being more systematic in Europe about addressing those risks. We have published the first ever EU climate risk assessment, and this will be a regular exercise to show what are the challenges combined, and we will be coming with a legislation on adaptation to climate change in the EU to connect the dots in between what's happening at a national level, because there's a lot of connections that need to be made. There is a lot of implications for many sectors, including the electricity provision and transmission, and this is a collective effort for us to map all of those and to see how we can plug in the different elements of the resilience to the climate change that is happening. And it is very important to have at this table all the key players that are affected by climate change. And obviously this is something that will resonate not just with the businesses, but also with the people, and that underlines the need to mitigate, to reduce the emissions as quickly as possible, so that we are facing the impacts in the future at a minimal level, and also at a cost which will be much larger than if we are to reduce the emissions.
I was not expecting this one, but it's okay. No problem.
I know you can handle it.
Yeah, no, it's okay. No, I was just thinking that as a citizen, I think that a European citizen, I think Europe is very good at strategy level, not so good as we would like at the implementation level. Honestly speaking, this is my view, and if this is going to punish someone, sorry for that. What I'm trying to say is that when we read the Draghi, the late report, and this compass that came out last week, I think I can identify at least 3 levels of resilience when it comes to strategy. One could be the physical resilience, so the fact that we have this modernized infrastructure in place that allow us to face in a good way when we have this kind of events like the one that we just had in Ireland. This is the first level that I think it's correctly addressed in these reports. And I'm also referring here to the ACER report that came out December last year. Then we have this, what I would call the operational resilience, but it's about integrating the markets. I think Europe has been doing a great job on that, but now we also need to have the flexibility markets on top of this. But here, I would like to stress that we need grid-friendly flexibility. So I think this is really important, because our market, the way it's designed from the first package, is that the DSO is kind of an agnostic part. So we don't play the role of saying you should do this and that. We just are here to serve the citizens, meaning that the ones that driving the behavior of the citizens, namely when it comes to tariffs, are the suppliers, not the DSO. So we should make sure that we understand this concept, that it's not enough to change the tariffs, because in the end, what is driving the consumer behavior is not really what the DSO is doing, but what the market players are doing. And that leads me to the final layer of resilience, which is the strategic one. And here I think that it's also correctly addressed in these documents is the need that to put in place this kind of green value chain for products, and also to upskilling, reskilling, or whatever is skilling our workers, our labor force, our European citizens as a whole. So my final message on this, I think, again, would be we need to accelerate. I think we are very slow in the process. What we really need now is to focus on implementation.
Great. I don't know, we can maybe take one question from the audience. Is there any burning questions out there? I don't want to put us any further behind schedule today, so I'm going to jump into our final stretch after this. I can't really see. Right in the front. And it's very appropriate because I have to apologize for our Donald Trump level diversity of this panel. And there's no women, so at least we get a question from, you know.
Only slightly diverse. So this is a question for Jan. You said, you know, in order to make this happen, we need to build. Build, baby, build, I think was your quote. I don't know if you followed what's happened in Pakistan last year. And I think it's, and for those of you in the audience who might not have, Pakistan's peak grid demand is around 30 gigawatts. Last year they installed about 15 gigawatts of solar PV, and they've seen demand decrease across their grid. Now, that matters also for Europe, where we have across Belgium and, well, across Germany more solar installed than there is peak demand, and Belgium will soon be in a similar place. And of course, in winter, it's not sunny and all of these sorts of things. But solar combined with storage starts doing really interesting things, and the cost declines of solar and storage are phenomenal. And we've had a discussion around resilience, and across the US, you see microgrids. So if you bring this all together, you say, sorry, and the last thing is, as humans, we're really bad about forecasting nonlinear systems. So COVID, great case in point, but you know, what's happening at grid level is also nonlinear. You're seeing exponential growth in, I'm going to say it, heat pumps, in EVs, in renewables, and I know it's a bit wobbly, but it is happening. So there is the received wisdom out there that we need to build. Do we need to be a little bit more humble and say, actually, there are some really plausible worlds where that's the wrong thing to do, and for climate resilience and for other things, we should be thinking about our systems differently. Sorry, that was a bit long.
I see you have 40 seconds to answer the question, though. Yeah, you're right. Last year in Europe, I think it was 65 gigawatts of solar, and every year, so that's like 20 or 10 to, let's say 10, 12 nuclear reactors equivalent of solar that's put in the grid. But also on the other hand, you have two things going on. Also a lot of wind offshore. So it's a combination of those two. And this wind offshore really needs not only the big lines, but also will provide, finally, electricity also for the electric vehicles that are in the grid. So it's a little bit a more mixed picture than in Pakistan, indeed, where the grid was already weak and they imported lots, and now also they don't have this winter-summer issue so much as here in the northwestern Europe. So I think the picture is more complicated. And we at Energyville, we try to optimize the whole system for decarbonization in certain steps in time. And then we see that, well, first of all, we're going to use a lot more electricity. So more electrons, less molecules. And also in terms of kilowatt hours, you need less electrons to replace a lot of kilowatt hours more of molecules. So there will be more exchange of electrons within the grid. And sometimes at the local level you can reduce that, you can make it more smart. And certainly with regard to resilience, those microgrid ideas, so using the inverter capabilities of cars, of batteries, vehicle to grid and so forth and so on, is something that we should use. That's an opportunity. And, but all in all, we need far more electrons that are going around. So that's why I said, don't hesitate. And Additionally, it's in a sector that has not grown for the last 20 years. I don't know if everybody knows that, but in 2008, it was about the same amount of electricity used in Europe as today. And now we say we're going to double or triple in just a few decades. So it's a complete reversal. And that's why I stress that aspect, although I know that he can try to reduce this build, baby, build as much as possible. But even then, you still need to build and not to hesitate too long. And that's my take on that.
One last stat. The DSO Observatory in 2018, the average asset utilization at low voltage level was between 2 and 21%.
Yeah.
That's the average utilization, and yes, there will be places you need to build, but it says there's a lot of room to double or triple without significant grid investment. And optionality and resilience suggests you need to be thinking about those other options.
Yeah, just if I may comment that very shortly, because it's really one figure that should be correct. I don't know the figure for my country, but should be around that, 1/5 of the value. I mean, you mentioned that the peak is very different than the average value. And that is not the fault of the DSO. That is the way we organize our society. It's not the problem of the one that manages the pipes and lines. That is why I claim for grid-friend flexibility. The way we organize our markets does not allow to synchronize consumer behavior with behavior of the power windmills and all this generation stuff. And the fact is that we are suffering also with that, because in the end we are having a surplus of energy circulating reversely in our networks, applying the network losses and creating more cost to the system that in the end goes to the final customer. This is why we think that it's important to be transparent on the process, to be technical when it needs to be technical, not to stay at the policy level only. I can also speak at policy level, but I think it's very important to give the details of the technical stuff, because in the end, it's all about electrons and physics. So we need to be aware of that. Thank you.
Okay, we're going to come back to this when I wrap up, but let's go this way down, and you got just a very quick top priority innovation need for dealing with resilience.
I think we need to be smart. We need to work together, the businesses, the governments, the European governments, and the businesses telling the governments what they need in order to deliver the services. And this is the time. This is the time when this whole clean industrial deal will be opening up and moving forward. And I think this is the moment when the governments should hear from the businesses how they can work together at the national and in particular European level.
Communication.
Yeah, flexibility is key to solve this and to have this acceleration that we already have. And with that comes with connected flexible assets on a platform comes security threats. And in my case, this year we are spending a lot of money to penetration test. We are hiring companies that is trying to hack our platform and also comes to our company physically and trying to steal information from our employees. And you have to do this kind of a penetration test to make sure that you have a resilient system, even if it's flexible assets. Yeah.
Approaches for cybersecurity. Very good.
Well, I would mention one topic that maybe is not normally considered innovation, but I think if it's properly interpreted, which is interoperability. I think what we need is to bring interoperability to a completely different level, and that's critical because we will have an incredible amount of programmable intelligent devices all around, which means we can feed the grid wherever we want, as long as these things can talk to each other, talk to the grid operators in a completely new level with what we are doing today. And this is only bringing interoperability to a completely different level, breaking all the data silos we have and making this possible. I think this will transform radically the way we use the infrastructure.
Interoperability, right on.
Okay, I think I go in the same line, also being a little bit technical on this. I would say if I have to select one innovation would be synthetic data. This is the one that comes from generative AI. And the reason being that I think we need really to improve trust from different parties. And with this Gen AI stuff, we can build a lot of new scenarios out of the blue. Of course, we need to collect first the data to build our own models. But the fact is that with that, we can develop different scenarios. We can be transparent in the way we dialogue with policymakers and regulators. And in the end, we can also incorporate the way consumers behave. So I think could be a game changer here. Thank you.
I think a lot has been said, and I just want to stress what you said before, grid-friendly flexibility and all the innovations that are needed for that. And that's on the regulatory side as well on the technical side. There are many, many things, and also on the data side, indeed, there are many things to be done, but grid-friendly flexibility, I think, is the key. Yeah.
Yeah, thank you. I agree that interoperability is important. It might be necessary, but perhaps not sufficient condition. Here I would just add a last point based on microgrids. I think we should start as DSO designing and better collaborating to understand, for instance, which capabilities should provide power electronics connected to our grids. If we want to operate microgrids in Ireland, we need to have, for instance, move from grid follower to grid forming technologies. So I think in order to exploit capacities, we also need that these communicating devices can also provide what is needed and also be able to align in our how the system is operated. And I think this is something we need to deep dive in innovative processes in projects. Thank you.
Great. And I'll jump on this question for mine in terms of, we've been talking about flexibility as a resource, but we don't include resilience in the value stream for that flexibility often enough. We've made it very difficult in Europe to enable microgrids, whether it's at the individual consumer level or the neighborhood level or the community level. But there's huge potential. Vehicle to grid is literally around the corner. We already have distributed resources and energy storage, and I wish more communities would have had that capability in the past week in Ireland, because they stepped up and found some backup generator for the GAA club and made a facility that could be an emergency facility for people that didn't have power, but it was all ad hoc. We didn't plan for it. And so the value proposition to include resilience as we're talking about flexibility is a huge opportunity. And I want to thank the panel. It's been a great discussion, and I'll turn it back over. Thanks. No, we were in Belfast.
Exactly.
Thank you so much to Mark and the panel. And we have one last presentation before lunch. And I would like to call my former colleague from the National Energy Agency, Simon Bennett, who will give a presentation to give some insights on what's happening with innovation. I think also using some work that they've done together with the European Patent Office. So it really brings together both the International Energy Agency and the Patent Office's work, and really gives some insights to what's happening in innovation in the energy sector. So Simon, the floor is yours.
Okay, thank you for the kind introduction. Thank you for the kind invitation to the International Energy Agency to speak today. I will hopefully be able to, to keep people's attention on this topic for another 15 minutes or so as we go into the lunch break, to present some work that the IEA has done in this area, actually across a number of reports that I think are relevant. I'm not going to introduce any new topics. I've been here all morning. I've heard that the things I'm going to talk about have already been mentioned in most of the panels and most of the speeches. But this is going to be a talk that talks a lot about technology innovation. The disclaimer here is that the IEA is well aware that the problems that we're talking about require innovation in a number of different areas, from regulation to institutional design to pricing, market structure, all of these things. We looked a little bit about the technology innovation. I'll give you some background as to why we did that, drawing on a number of IEA reports. Here's some reports. Here's a slide that I'm not going to dwell on, given time. This is the one that I thought would make a great way into the topic. Let's put all of the lines up on the chart. This is at a global level. The International Energy Agency, as many of you might know, is an intergovernmental organization that looks at energy from an international, worldwide perspective. So this is world electricity generation from 2010 to 2035. It is changing and it is growing. And so the background to this is electrification and it is variability of sources. And we can see here, the stark thing is that by the end of this decade, globally, we think that solar PV becomes the largest source of electricity generation on the planet. And that is in our scenario that looks at what would happen if governments implement all of the policies that they have on the statute books today, the ones that they're committed to. This is not what happens if all the governments successfully manage to implement their pledges to comply with the Paris Agreement to reach carbon neutrality by 2050. These are the policies that are already being in the final stages of development or are being developed and implemented today. This is a very dynamic and changing environment. In terms of electricity demand has been growing over the last decade at about double the rate of energy demand in total. And over the period we're looking at here, out to 2035, it grows at around 6 times the pace of energy demand in total. And that demand is now not only coming from emerging markets, which have been growing fast for some time, but advanced economies as well. The changes that we're seeing in terms, and this is quite well known, in terms of demand growth in some advanced economies is a story around data centers. Everybody's been reading the news. Everyone knows that data centers are going to be a big thing. But when we ran the numbers, it's a bigger story about electric vehicles. And when you add on top of that cooling demand, which is going to come from wealth and responses to climate change, that's what pushes up demand in North America and Europe. And this is not a North American story only. After a decade or so of stagnation of electricity demand in Europe, we see that it is going to increase by something like 40% over the time frame that is being looked at here. Investment in the power sector has been growing. I'm not going to talk through what the scenarios say from our modeling. It needs to grow much faster. In our sort of policy continuity scenario, then it needs to grow by about another 50%. But at the moment, for every dollar that is spent globally in electricity generation assets, only 60 cents is being spent in transmission and distribution. And that's in a world in which we need to make our electricity grids more secure, more resilient. We've been talking about that just now in that great panel. But also, from our modeling, we think globally we need to add about 50 million kilometers of cables to 2050 if we're going to reach some of the pledges that countries have to transform their energy systems. And 93% of the transmission and distribution system today is at the distribution level in terms of the kilometers of cables. This is a DSO problem to a large extent, or indeed an opportunity. And we wanted to look a little bit about what that entails. That's something about batteries. But the issue around flexibility, when we model that, the changes and growth in the grids out to 2050, becomes really a question of splitting out the short-term needs and the longer-term seasonal needs. So I'm focusing here on the chart that's on the right and how multicolored, especially the second column, the 2050 column, becomes in terms of the different types of flexibility that we think make up a secure energy system that is highly electrified. And you'll see that the bigger area of growth is in demand-side response, DSR, largely from electric vehicles, and also from batteries. Now, batteries in that type of scenario go from, or at least in order to add something like a tripling of renewable capacity this decade, which is one of our scenarios, you have to grow battery capacity 6 times, stationary battery capacity, in order to be able to provide the flexibility requirements. So there are technology problems in the way that this is constructed, in the way that we achieve the pace of change that is being, that is the ambition of governments, of companies, of many citizens around the world. And so we started to think about what that means for the innovation part. And I sit in the technology division of the International Energy Agency, and we designed a study, as Charles was saying, with the European Patent Office to look at patenting. And we carved up the technology landscape around grids, transmission and distribution, in a simple way between the physical side and the smart side. And we really wanted to capture what's happening in the physical side in terms of cables and transformers and inverters, as well as the interesting new smart things, the digital things that other people would like to focus on. And it was very interesting that we were seeing similar levels of innovation efforts between the physical and the smart side. And this gets into a lot of detail. We've got smart inverters in our data set. We've got smart transformers, grid forming inverters, DERMS, all the rest of it. It's all there. But the starting point for the study was to look at inputs to the innovation system. And the good news is that globally, in terms of financial inputs to research and development in power and grid sectors, we've got growth. And we've got growth in terms of the companies that are involved in this, as well as the government funding. When you look at the European part of that, the story is not quite as positive. European public funding of research and development for power and grid sectors has actually been pretty level over the last 8 years. So that's not necessarily a bad thing. Europe might be getting much more efficient at spending its R&D dollars. What does that start to translate into? I keep saying dollars, don't I? I'm in Brussels, I should be talking in euros. What does that translate into when we look at some of the outputs of the innovation work? And this is the trend of patenting for grid technologies since 2002, and it's really interesting to see this. We've done a number of different studies of energy technologies with the EPO, and this is one of the first times we saw such a stark ramp up in this period between 2009 and 2013. That's very steep growth in innovation effort that was leading to patenting. That growth was largely led by the European Union and Japan. Actually, a bit broader than the European Union because our Swiss neighbors are pretty hot on grids innovation too. So Europe and Japan are pushing that ahead. Europe especially on physical grid technologies, Japan especially on smart grid technologies. And then around 2030, my hypothesis here is that we reach the end of some competition for dominance in some standardization issues. We have the growth of EV charging in smart grids and smart meters especially as well. We got some protocols settled. And then the innovation begins to stagnate, but still stays at a very high level. The interesting thing I think about this chart is the growth that we've seen in recent times. That's slightly outgrowing total patenting in the energy sector in general, and it's being led by China and to some extent the United States, and it's on the smart grid side. And in 2022, which is the latest data for which patent information is available, was the first year that China overtook the European Union in terms of the volume of patent applications in grid technologies. This is the breakdown, as I said, between smart grids, physical grids. We actually separated out stationary storage from this separately, and you can see that the real growth recently has been mostly on the smart side. And when we do the regional decomposition of that smart grid patenting, I think we see again that you have the light green, which is Japan, and the darker green, which is the United States, over 10 years cumulatively, are really dominating in that space. Those are the sources of the most patent applications. We all know that not every patent application turns into a commercial product, but it's a proxy that we're using. And then in the last few years, that's when we see that the red bar, China, has expanded as well. Europe has been getting a larger share of the smart metering patenting, but less on the virtual power plants and demand response. I wouldn't like to hypothesize about what that means exactly in practice, but I think given the title of this segment was food for thought, I think that some of this is food for thought. We heard a little bit in the last panel about artificial intelligence and the power that that can have, and we're doing a big project at the moment at the IEA on AI. And we looked at the patent applications for the use of AI in grid-related inventions, and this is really quite astonishing. We didn't expect to see that the red line would grow at this kind of rate. That's 35% compound annual growth, year-on-year growth in AI patenting just since about 2015. This is the global picture, overtaken all of those other forms of enabling digital technologies for smart grids. So this is the combination of AI or cloud data with a particular grid application. And that's now become the highest level there. I see no reason, given the papers you read, the amount of activity, the number of startups being launched, why this isn't going to continue exponentially, at least in the short term. The work that we're doing at the IEA is both on the use of AI to optimize electricity or energy supplies and use, but also on how much energy demand is going to actually come from the training and the use of artificial intelligence. And the report that we're working on that will come out, I think, on the 9th of April. So please do look out for it. Hopefully in there we will do some more breakdowns of the patenting as well and look at the real intersection of AI applications for different parts of the energy sector. So that's a quick run through some of the charts that we had. I've talked about inputs, I've talked about outputs related to innovation. I would say this is, in a way, this starts to get more towards the outcomes, where some of those patents have been taken on by startups. We've got some information in the report about just how many startups actually have patents. It's a big source of value for them. And on the left, we have the startups that are raising money in energy storage. On the right, left, it's related to power and grid technologies. This is sort of in order to get reasonable statistics, this is the lowest level of disaggregation we would go to. I think what's interesting about this is the huge growth in 2021. Don't worry too much about the drop-off in the last couple of years. We will see another drop-off in 2024. We've just crunched the numbers this week for our venture capital data, but that is in line with clean tech and global investment in startups, more generally, with the exception of artificial intelligence. So we've got huge growth. It's being maintained. Lots of startups are raising money in this area. It's reaching percentages that are like 20% of total energy venture capital raised on the storage side, 6% on the power and grid side. And Europe is performing, you can look at this glass half full, you can look at this glass half empty. Europe is one of the biggest regions for venture capital in the energy sector and in grids and storage. Whether or not it's really sort of making inroads into the United States share, or indeed what we're seeing in China and elsewhere in the world, I think is yet to be seen. We would want to see that more steady growth, I think, in the light blue part of that column. I think there's a lot of expectation in the Commission and in other organizations around that. And that brings me to a final point I wanted to make before closing, which is that innovation in clean energy technologies is becoming a very, very large market opportunity. And this chart is taken from our Energy Technology Perspectives report that we published in October last year. The summation of the markets that you can see here is really 5 technologies. It's heat pumps, electrolyzers, solar PV, wind, and electric vehicles, and all of the batteries and components that go into electric vehicles. Because those are the ones where we have good data on manufacturing capacity and prices and information. And it was a huge task to bring that all together at the global level. I think for the purposes of what I'm saying here, it's the size of the squares that is important, that we reach under current policy settings. This is not the net zero scenario, a market size of $2 trillion per year by 2035. and that is in the order very close to what we have for oil and gas today in terms of the trade of clean energy components and equipment around the world. This is why governments are competing now in this area to secure as much of that value for themselves. And I think it will be the same in many of these DSO-related grid technologies. And although some of the software aspects are not going to be physically traded, there is a huge market opportunity here to be grasped by being able to make those globally interoperable and have sales overseas and around the world. This is work that we will continue to develop within the IEA so that we have the trade statistics to go along with our energy flows in our scenarios. We'd be very interested to learn about whether there's particular technologies on the distribution grid side or particular data sets that we might start to include into that so that we can give policymakers the best advice possible on all the different technologies in the energy sector. As food for thought, I put together a few thoughts. I can read through these, but if people would like to ask questions, I guess we can start to look and see if there are hands going up as I do so. But we have the bigger point about electricity demand growth and how that is 6 times as fast from now until 2035 globally. And it is a European story to some extent now, as well as an emerging market story. We have the story about investment, that we need to accelerate investment on the grid side as we accelerate investment on the renewable side. I think that's very well known from the discussions already this morning. I think that security and resilience are really becoming a big topic globally, and we now have the news stories regularly that put this at the front of people's minds, and that we can see how some of that patenting activity since the beginning of the century, since 2002, are translating into market opportunities and investment. Europe has been at the forefront of the physical grid side. I think the data that we looked at with the European Patent Office raises questions about the smart grid side and how it's going to secure global leadership on that side. And then I think there are some interesting things to think through around the adoption and integration of new technologies that we see that are at a very early stage today, and how we make sure that the grids and the DSOs are ready for that and the frameworks in place to do so. I'll bring my talk to a close there so that everybody can either ask questions if there are any or break for lunch, but thank you all for your attention.
Thank you very much for the insightful presentation. I have 2 questions indeed. One is related to this last chart. So when you say that smart grids are not on top of the European agenda, I mean DSOs or DSOs, what do you see with the other geographies? I mean, I think the United States are also not in that position. Maybe China or Japan, I don't know. You probably know better than me. And that is a little bit concerning. The second one is on artificial intelligence that you mentioned. So it's very nice to see that graph. Could you elaborate a little bit more on the way you decompose the graph when it comes to Europe? So what is the role of Europe in that exponential curve that we see there?
I will try, but this is off the top of my head. So the patent study is something that I work very closely on myself, so I know a little bit about the data. Some of the other big picture elements that I presented are from other IEA work. The IEA, it produces an astonishing amount of reports and information. I apologize for anyone who tries to keep up with what we do. It's hard from the inside as well to keep up with all of the information. So I think the point around smart versus physical grids, Europe versus the rest of the world, is not conclusive. And certainly on the European side, you are much closer to what is really happening on the ground. What we were seeing in the global data on the patenting is certainly that there are regions that are making more innovation effort. Some regions have a higher propensity to patent anyway. Let's leave that to one side. Compared to Europe, and that the rate of startup formation, things in the United States around earlier stage smart grid applications is slightly higher. I think that's true. I think it's probably a little bit much for me to claim that Europe has a competitive weakness, but I think the data that we've looked at, compared to the rhetoric that you see on the policy side, puts a question mark about whether there is as good a connection between the policy side and the outcomes as we'd like to see. On AI, for some of these patenting areas, I think we're getting sort of 200 international patent families globally on that, which is large because each one comprises a number of different patents that are patented in different offices around the world. But it doesn't necessarily support detailed statistics once you start to break that down regionally. But the biggest growth area on the AI side is China, when we do the regional breakdown. China, followed then United States, Europe, and Japan after that.
I think we'll, in the interest of time, we'll end it there. Thank you very much, and a round of applause again for Simon. And before we go from food for thought to actual food, I would like to remind you again that we will have a vote on for our second digital award, and so please see the booth. Put this into your phone so you're ready, because you will only have 2 minutes to vote once all the pitches are finished. So it's good to have it prepared already on Slido, which I think most of you are familiar with. And with that, please enjoy your lunch.